Hello, today we will present about Chapter 3, Integration by DBM20023, Engineering Mathematics 2.
Hi, my name is Annabelle Garcia and my number matrix is 07DKA23F2027.
Hi, my name is Raiti Binti Jeffrey, number matrix 07DKA23F2003.
My name is Chandra Asai, number matrix 07DKA23F2023.
Hi, my name is Helishila Charlene Stimus, number matrix 07DKA23F2041. Learning outcome. On completing this subtopic, students should be able to calculate the graph area along x-axis or y-axis under a curve or bounded by a curve and a straight line with illustrated graph. Second, calculate the volume of a region which is generated through 360 degree about the x-axis or y-axis, bounded by a curve or bounded by a curve and a straight line with illustrated graph. Introduction. A line integral is a mathematical concept that involves integrating a function along a curve in a coordinate system. It can also be called a path integral, curve integral, or curvilinear integral. The function being integrated can be a scalar field or a vector field. Here are something to know about the integrals. First, application. Line integrals have many applications, including calculating the mass of a wire from its density and calculating the area of three-dimensional surface. Vector field interpretation. For vector fields, the line integrals can be interpreted as the amount of work done on a particle by a force field as it moves along a curve. Third, scalar field interpretation. In a two-dimensional field, the line integrals of a curve along a scalar field is the same as the area under a curved trace over the surface defined by the field. Last, curve direction. The curve negative c is the same curve as c, but with the direction reverse. In a two-dimensional field, the value at each point can be thought of as a head of a surface embedded in three dimensions. The line integral of a curve along the scalar field is equivalent to the area under a curved trace over the surface defined by the field.
Okay, now we look at the question. The question 1 we find the area of the region enclosed by a curve. X is equal y squared minus 2 and a line y is equal x. Okay, first we can see area between a curve and the x-axis. We look at the graph. It's a type of a graph that involves a curve against the x-axis. When we look at the graph, they are A and B. A and B are the limits area of bounded region. So, how do we find the area between a curve and the x-axis? When we look at this area, it is heading towards the x-axis. So, when on the x-axis, we will use the symbol dx, where A is the area of the shaded region, lower limit, upper limit, and the function fx, which is the function y. So, the formula to find the area of the shaded region with the x-axis is ax is equal integral for limit a and b. So if you can see the notes on the slide, if the shaded area is negative value, the shade area is under the x-axis. Now, remove the area between a curve and the y-axis. How do we know it's the y-axis? Let's look at the dashed line. It points towards the y-axis. When it comes to the y-axis, lower limit and upper limit, we will refer to the y-axis, which when for the y-axis, the integration calculation will become dy and the formula will become fy, which is the function of x. So the formula to find the area of the shaded region with y-axis is y is equal integral for limit a and b. See there, if the shaded area is negative value, the shaded area is at the left side of the y-axis.
So now we'll be doing the calculation, and the formula that we're going to use is a shaded equals to a line minus a curve. So the limitation for a line is 2 and negative 1. Integral y dx. And then we will change the y dx to x dx. Then integrate x, and it will be in bracket x squared per 2 in bracket, and put the limitation at the side. Now we will solve the limitation when x equals to 2, comma, when x equals to negative 1. Then in bracket 2 squared over 2 in close bracket minus in bracket negative 1 square over 2 close bracket. Then it will be 2 minus 1 over 2, and the final answer is 3 over 2. So for the a curve, the limitation is 2 and negative 1. Integration x dy, and then limitation 2 negative 1 integration y square minus 2 dy, and then in bracket y power of 3 over 3 minus 2y close bracket, and the limitation is 2 and negative 1.
Now we will solve the limitation when x equal to 2, comma, when x equal to negative 1. Then in bracket 2 power 3 over 3 minus 2 times 2 close bracket, minus in bracket negative 1 power 3 over 3 minus 2 negative 1 close bracket. Then it will be negative 4 over 3 minus 5 over 3, and the final answer is negative 3. For the final solution is a shaded equals to a lines minus a curve, then 3 over 2 minus negative 3 and then 3 over 2 plus 3, and the final answer is 9 over 2 units. For the formulation, integration is a mathematical technique to calculate the area under a curve. There are multiple methods for integration, of which we explore integration by parts in this article. Here we derive its integration by parts formula and also understand its application.